All right, so now we're going to be looking at page 82. We're going to do number 67 and 68. We're going to do only parts B and C for each one of these. So number 67, it's about break-even analysis. So it says use the revenue function from problem 65 and the given cost function where X is millions of chips, R of X and C of X are in millions of dollars. Both of these functions have a domain of X is between 1 and 20. So let me write down what they give you. They give you a revenue function, R of X, that's money coming in, right? Revenue is this. And then cost, that's the money it takes to run the business, has a fixed cost plus a variable cost here. All right. And X is in millions of chips. And we're using the information from problem 65. So those are microchips, okay, for computers. So we have X is in millions of chips. These are measured, R of X and C of X are measured in millions of dollars. And the domain is that X is an element of the interval 120. That's written a little different than they wrote it in here. But this is our domain. Okay. Hold on a second, I just got a message. 4dx, snooze that. All right, so part B, we're going to go right to part B. Find the break-even points to the nearest 1,000 chips. The break-even point. Well, break-even point is when profit is 0. Now, profit we don't have listed here. We have to remember that profit is revenue minus cost. And so we want the difference between these two to be 0, which I can do. I can write down the revenue function, I can subtract the cost function and set it equal to 0. So I'm creating an equation. When they say find the break-even points, you're going to create an equation. So here's X, 75 minus 3X, that's your revenue, minus your cost. Now notice on my cost, I put it in parentheses because I'm going to subtract the entire cost function. If I don't put parentheses, you're only going to subtract this and that'll be added and that'll be incorrect. And we need that to be 0. Okay, revenue minus cost must be 0. So I'm going to distribute the X through here, 75X minus 3X squared minus 125 minus 16X must equal 0. So that's what I get when I distribute the X through here and the negative sign through here. I'm going to collect like terms and putting in descending order. So negative 3X squared is the only X squared term I have. I have 75 X's. I'm going to take away 16 X's, which is going to be what, 59? Let's see, I can't do simple math. 6 and 5, yeah, 59X. So plus 59X, and then minus 125 equals 0. Okay, at this point, we try and see what we can do to solve this. This is a quadratic equation, and unfortunately, I do not believe this is going to factor easily, so we're going to just go to the quadratic formula. So my quadratic formula tells me that the solutions to this are going to be negative b plus or minus the square root b squared minus 4ac all over 2a. You should have the formula, but I'm just going to write it out. So negative b is negative 59 plus or minus the square root of, numbers are going to get big here, b squared. So 59 squared is 3,481. That's this number squared. Okay, minus 4 times a, which is negative 3, times c, which is negative 125. All of this divided by 2 times a. So that's my quadratic formula. I'm going to go ahead and figure out what this is right here. So I like to do it this way. 4 times negative 3 times negative 125. That gives me, without the minus sign, that gives me a positive 1,500, but then I'm going to subtract it. So all of this here really becomes minus 1,500. So I'm taking this number, 3481, minus 1,500, and I get 1981. So negative 59 plus or minus the square root of 1981 all over, multiply those, you get negative 6. So now on my calculator, I've got to take the square root of 1981. So 1981 square root, 44.5, that's good enough. So this becomes, let me do it over here. Here's what I've got so far. I've got that x must be equal to negative 59 plus or minus, now I put in that, the square root was 44.5 all over negative 6. And now what I'm going to do is look at both of the scenarios where we have plus or minus, right? So I have plus or minus here. So this is going to spit out two answers. The plus scenario and the minus scenario. So if it's the plus, it's negative 59 plus 44.5 all over negative 6. And if it's the minus, it's negative 59 minus 44.5 all over negative 6. So let's do this on our calculator. I'm going to do this on top first. So negative 59 plus 44.5 gives me about negative 14.5. Then divide that by negative 6. And I get approximately 2.42, approximately. And then on this one, this is negative 59 minus 44.5, which is negative 103.5. Then divide that by negative 6. And I get approximately, well, it's exactly actually 17.25. So the break-even points that we found are these two values of x. So remember, x was the number of chips in millions. So if we manufacture 2.42 million chips, manufacture and sell, then our profit will be 0. Our revenue will be, our revenue minus cost, or I should say our revenue will equal our cost. Same here. If we manufacture 17.25 million chips, then our profit will be 0. So we don't want to do that, right? We want profit to be positive, not 0. But that's what it asks for. Okay, so part C is where we get to that next question. Part C says, for what values of x will a loss occur? And then it says a profit. So we have to understand a little bit about what's going on here, and I've erased it. Remember that when we did revenue minus cost, we took this and subtracted this. We had negative 3x squared, and then it was plus 59x, and then it was minus 125. Yeah, okay. And then we had set that equal to 0. You remember we did that. Well, without setting it equal to 0, this by itself is profit. That's our profit function. It's revenue minus cost. Of course, setting it equal to 0 gives us our break-even points, but by itself, this is our profit function. So we want to know in part C, when is our profit, when will we have profit, when will we have loss? So we have to know a little bit about what this function looks like. It is a quadratic function because it has x squared, and the coefficient is negative. Now we know parabolas either open up or down. This negative number in front tells us it opens down. So if I were to graph this right now, I know that it goes like this, okay? I also know that at these two values, 2.42 and 17.25, my profit is 0. which means that that graph hits the x-axis here. And if it opens like this, then, or if it looks like that, then our profit function is going to look something like this. And so they want to know, when are we going to have loss and when are we going to have profit? Well, I just happen to have two colors here that are good. Look, anytime between here and here, our profit function is above the x-axis, which means our profit is positive. So we're actually making money here, right? Plus, we're in the green, okay? But if we go anything less than this or greater than this in terms of millions of chips, our function's going to be below the x-axis, which means we're going to be losing money. We lose money here and we lose money over here. Now remember the domain of this. They had said the domain, our x's were in the interval 1 to 20. So we can't keep going. We would stop here at 1 and we would stop up here at 20, okay? So if we're being asked, where is their loss? Okay, so where does the loss occur? When are we losing money? Loss occurs over here. I'm going to do it on a number line so you can see a little better. We have to stay between 1 and we have to stay between 20. We know that at 2.42 we have something interesting happening, and we know at 17.25 we have something interesting happening. We know that, I'll do it this way. If you break up our number line, okay, we know that between 2.42 and 17.25, we have positive profit. And then we also know that to the left of 2.42 over here, and between 1 and 2.42, we have negative profit. And over here we have negative profit. So we are going to have loss in this interval right here. And we are going to have profit in that interval. So we just need to write those down in interval notation. So loss will occur here, which means from 1 to 2.42, not including 2.42, because at 2.42 you don't have loss, you just have no profit, no loss, just break even, right? So we have loss there, or union with 17.25 to 20. Again, don't include 17.25 because that's not loss, that's break even. So that's where your loss occurs if x is in here. And then your gain or profit, you'll have positive gain if you're between here and here. So that's between, x is an element of 2.42 to 17.25. All right, so let's just summarize this. If you manufacture and sell anywhere between 1 million to 2.42 million chips, or 17.25 million to 20 million chips, if that's what you manufacture and sell, anything in that region, you're going to be losing money. If you keep your production and sales of chips between 2.42 million and 17.25 million, you should be in the green. You should be making money. Now, of course, the most natural question is, how many chips should you manufacture and sell to have the highest profit, which would mean we want that highest point, which is something we can do, but it's not being asked in this question. Okay, I think on the next problem for number 68, it's the exact same thing. So the numbers are bigger and it's probably a little uglier, but the method is exactly the same as this method. So I'm going to allow you to do number 68, and I'm not going to show it on video. I think you can handle that. If you have questions over it, you can ask me in class. All right, that's it for this section.